What is the rarest thing in the universe? Is it black holes, quasars, or the birth of a star? None of those things are the rarest thing in the universe, because they've been observed many times over the years. But there is something that we have only seen about 30 times over the past 3 billion years, and we still don't understand it. And astronomers think that one of these mysterious events is happening right now. It could be happening as we speak. We don't know because it's invisible to the naked eye. It's hidden in plain sight. This is a special Star Mysteries episode, where we will take a look at the 30 strangest stars in the Milky Way. Some of them could go supernova at any moment and release more energy than 1 billion suns. Others are so magnetically charged that they could rip apart planets from miles away. And we don't even know if all of them are still out there, but we think they are. These are not normal stars. They are cosmic anomalies. Over billions of years, astronomers have discovered approximately 30 of these weird stars. All of them are different, but they seem to follow a few common rules. They are ancient. All of them are at least 100 times heavier than our Sun, and they all seem to have some kind of ultra-strong force acting upon them, a force powerful enough to distort them into strange shapes, tear apart molecules and release colossal amounts of energy, and it happens suddenly. Stars that were dormant for billions of years will suddenly burst into action and shine brighter than 10 trillion suns. That's why some call these stars dormant giants. And when they wake up, they release an incredible amount of energy. You might be thinking this sounds pretty cool. And yeah, it is. If it happened somewhere far, far away, like in another galaxy, we wouldn't even notice it. But this happens in our galaxy. Every time one of these stars goes off, we feel it. When SGR 180620 exploded in 2004, the flare hit Earth and knocked out 20% of the world's X-ray satellites. And in 2020, a similar event caused by another star left its mark on the DNA of people and animals on Earth. The mutation rate increased dramatically for a few weeks. They are called soft gamma repeater stars. They are magnetars, a category of neutron stars with ultra-strong magnetic fields. Astronomers don't fully understand them, but they know that they have something to do with the rotation of these old stars and the energy that is released when they collapse. They also know that they create huge flares. One of the biggest ever recorded was created by SGR 180620. This single flare was so bright that it was visible from Earth. Now, imagine if this had happened just a few thousand years ago when human civilization was just getting started. Maybe it would have seemed like a new god was angry at humans and was punishing them for their sins. What's scary about these flares is that they can reach us, even though they originate from millions of light years away. Most of the soft gamma repeaters are located in the center of the Milky Way, very close to us, and the energy they emit can travel through the galaxy, stripping away the ozone layer and irradiating the surface of our planet with deadly radiation. We have no idea how often this has happened in the past, but we do know that this is exactly what happened in 2020. A study from researchers at Penn State used data from NASA's Fermi Gamma Ray Space Telescope and the WIND and Ulysses spacecraft to study the February 2020 event. They concluded that it originated from a soft gamma repeater called SGR 501074. This star is located about 26,000 light-years away. But despite the distance, the flare stripped away the Earth's ozone layer and bombarded our planet with gamma rays. In just 2 days, the flux of gamma rays increased 100 times. It may not sound like a big deal, but most of the stars in the Milky Way are much bigger and more active than SGR 501074, so there is always the chance that we will be hit by a much stronger flare in the future. In fact, astronomers believe that an event like this could happen every 100 or 200 years. But until we can figure out what these stars are up to, we won't be able to tell. But not all soft gamma repeaters are like this. There are also hard gamma repeaters. They are smaller and less massive, but their flares are more frequent. They also seem to target Earth more often, and we are still trying to figure out why. It seems like some of these stars are extra interested in what's going on here. Astronomers use the James Webb Space Telescope to track one of these repeaters called SGR 17452957. It is a very interesting object because it is the closest soft gamma repeater to us. It is located in the constellation of the Southern Cross, just 4,000 light-years away. For 2 months, the space telescope tracked the star, hoping to detect an outburst, but nothing happened. Still, scientists were able to learn some interesting things about the object. SGRJ 1745-2957 is not a single star. It is surrounded by gas and dust left over from a massive explosion that happened in the past. This helps astronomers better understand the evolution of magnetars and the debris they leave behind. But what if we were able to observe one of these outbursts as it happened? How would that help us? It would help us in so many ways. Right now, we only know of one event that we observed from start to finish. And that's what makes the study of SGR 180620 so important. It's the only time we've seen a flare develop over time, and it gives us a glimpse of what these stars are like. SGR 180620 is located 10,000 light-years away, almost in the galactic core. It first caught the attention of astronomers in December of 2004. On Christmas Day, it began releasing a steady stream of X-rays. Then, in mid-January, the activity stopped. But just 3 days later, on January 19th, the star exploded. The initial burst lasted just under 5 minutes. Then another one occurred about 2 hours later, and a third and final one was detected a day later. All of them were visible from Earth. It is believed that the first 2 bursts came from opposite poles of the star, and the third one was probably triggered by a cloud of gas between the two, a cloud that was created by previous outbursts. These 3 explosions released as much energy as 10 billion suns, and they left their mark on the Earth's atmosphere. In May 2005, NASA published an analysis of the impact of the flare on our planet. The radio wave burst generated a current in the ionosphere, triggering widespread disruptions in high-frequency radio communications. Aurorae were seen as far south as Florida and Hawaii. High-frequency radio blackout, global disruption of the ionosphere. All of that caused by a flare that happened 10,000 light-years away. For comparison, the Hiroshima atomic bomb released about 62 kilotons of TNT. The largest flare released about 10 septillion tons of TNT. That's 10 to the power of 24. To put it in perspective, the energy of the biggest flare is the equivalent of 10 billion times the destructive power of the atomic bomb dropped on Hiroshima. It is mind-boggling. Scientists continue to analyze data collected during the outburst. They want to find out if the emissions had an impact on the upper layers of the atmosphere. They also want to know if they can improve weather forecasting by learning more about the ionosphere and how it interacts with these explosions. And while they work on that, astronomers are searching the skies looking for a new outburst. This time they are targeting another star, a star with a name that has nothing to do with astronomy. Kepler's X-ray source number 17, or just KX17. Just like SGR 180620, it is also in the Milky Way, and just like its cousin, it is also an enigma. The difference is that CX17 doesn't really show signs of life, unless you count the countless X-ray bursts that have been detected coming from it. Each one of these bursts releases about as much energy as the Sun does in 4 days, and the star seems to keep doing this over and over again. Astronomers have been watching it since the early 1970s, and they've seen dozens of these X-ray bursts, but it hasn't exploded yet, at least not one that we know of. CX17 is a bit closer to us than SGR 180620. It is located just 2,800 light-years away, and astronomers are hoping that one day soon they will be able to study an outburst from this star. And when that happens, we might finally get answers. We might finally learn what these strange stars are. We might learn why they are so obsessed with Earth, and we might discover new physics that we didn't even know existed. As the saying goes, one person's trash is another person's treasure. And when it comes to these mysterious stars, we couldn't agree more. Thank you for watching. If you enjoyed the video, please subscribe and leave a comment. We always appreciate hearing what you have to say. Everyone who subscribed will be kept up to date on all of our latest discoveries and stories. We truly appreciate your support.